Department of Physics, Erode Sengundar Engineering College. In this session, the main topic to be covered are basic terms, elasticity, stress strain diagram and its application, torsional pendulum and torsional oscillation, bending of beams, ISEP girders and its application. Basic definitions and or basic terms. A deforming force is the first coming to you. It is a force which acting on a body on account of which its shape or size is going to be changed. In general, we can say deforming force is a force which tries to change the shape of the object. Restoring force. It is also a force. That force is developing inside the body. This force is equal and opposite to the deforming force. The deforming force may be written as F equal to minus Kx, where x is the displacement, k is a constant that depends upon the material. The negative sign indicates that the restoring force and deforming force are always equal and opposite. Rigid body. It is a type of body which does not undergo any changes when deforming force is acting on it. Elasticity. The property of a body by virtue of which it regains its original shape immediately after the deforming forces are removed is called elasticity. See, in these slides we are going to see and discuss about the golf ball and rubber band. The rubber band is daily used by us. Once we stretches the rubber band, it will elongate. After that, if we leave it, again it comes to the original position. The same thing is true in the case of golf ball. When we hit the ball shape will be changed. After that, immediately recover its original shape after getting hidden from the stick. In our daily life, clay mud, wax, lead, chewing gum, butter wax are some of the examples for plastic bodies. See, in these diagrams we are going to discuss about the elastic collision and inelastic collisions. If we use the ball to fall on the floor, the ball again return back to same position. Suppose if we leave the ball from our hand, the ball again will come to our hand. Suppose if we drop a plastic ball, that will hit the floor and it won't return back to our hand. That means in the case of inelastic collision, energy is lost, but in the case of elastic collision, energy is conserved. In this slide, the slide shows a elastic spring. Some load is applied on one end of the spring, whereas another end is fixed rigidly. As a result, the spring extends from original length to somewhat. After the removal of the load, the spring again came back to its original positions because of the restoring force developed in it. This type of spring is usually used in the cradles. See, the restoring force F acting on the spring is in a direction opposite to the displacement of the wire. The displacement is due to the load. In general, we can write that the restoring force F is equal to minus K into X. In this slide, we shall discuss about the stress and strain. Strain is nothing but the change. Stress is a force which is responsible to make changes in the object. In previously, they explained stress refers to the cause of a deformation. whereas strain refers to the effect of the deformation. The downward force F causes the displacement X in the case of spring. Even the force is due to the load applied at the free end. Thus, the stress is a force, the strain is the elongation. We can define the stress as force per unit area, that is, the restoring force developed per unit area of cross section. The deformed body is called as stress. Further, we can classify the stress into three types. If force is acting exactly perpendicular to the surface, then this type of stress is called normal stress. If not, if force is acting parallel to the surface of an object, that type of force is called tangential stress or tangential force. But in the bulk stress, the force is acting at all directions. Suppose if you consider a cube or bricks or chalk box, the forces are acting in all directions. That means top, bottom, left, right, front, back. 6 directions are subjected to the force. In these slides, we shall discuss about the tensile stress and compressive stress. A tensile stress occurs when equal and opposite forces are directed away from each other. See, in the first case, the tensile force is applied due to the load W. As a result, restoring force is developed in a direction opposite to the deforming force. This is the tensile stress. Whereas in the case of compressive stress, when equal and opposite forces are acting directed to each other, see, we are giving pushing in the object towards a rigid area. As a result, the pushing force and the restoring force are facing to each other. As a result, it will be compressed. Strain. The deforming force produced per unit magnitude is called strain. The ratio of change in dimension to the original dimension is called strain. Dimension may be length or in volume. Dimensions quantity has no unit. From these slides, we can explain the three types of strain: longitudinal strain, volume strain, and shearing strain. Longitudinal strains refers to changes in length along the lengthwise of the object. Volume strain deals about the changes in volume to the original volume, whereas in shearing strain, there is no changes in volume. There may be only changes in the shape. See, first we shall see the longitudinal strain. Longitudinal strains of a deformed body is defined as the ratio of the change in length of the body due to the deformations to its original length in the directions of the force. We can write in formula longitudinal strain is equal to change in length to the original length. As we saw in the earlier case, in a bulk strain, forces are acting perpendicular to all surfaces of them, bricks or chalk box or a cube. See, there are 6 faces. When forces is acting exactly perpendicular to all the 6 faces, then the body's volume will be changed. The change in volume is noted. The ratio between change in volume to the original volume is called bulk strain or volume strain. The last one is shearing strain. Suppose if we imagine a desk used for long days, more than 30 or 40 years, So if suppose want to move the desk, we just pull on the top surface of the table. At the time, the top surface alone make a little bit deviation compared to the base area. That means the legs in the base areas are always stable, whereas in the top sides there may be a little bit slide. That is why the perpendicular leg C and D displaced to the distance D dash and C dash, whereas the bottom positions of the legs are at the same position. The change in shape may be measured by measuring the distance between C and C dash or D and D dash. Then change in the shape divided by height of the leg. C dash divided by CB or BC will give the shearing strain. Elastic limit. It is a very interesting topic. Everything has some limit. This is true for the material also. When we give some stress within the elastic limit, there may be some changes. It is strain. The dimension or magnitude of the strain is directly proportional to stress. This is true within the elastic limit. Then what is elastic limit? It is a limit within which, when deforming force is acting, the body can regain its original shape or size even after the deforming force is removed. See here, they give the elastic limit is the maximum stress of a body can experience without becoming permanent deformation. If the stress exceeds the elastic limit, the final length will not be longer than the original length. See once again, if the stress exceeds the elastic limit, the final length will be longer than the original length. See, the original length is 2 meter. Load is attached at the other end of the strings. In the first case, there is some stretch. The stretch is within the elastic limit. In this case, when we remove the load, the body again regains its original length. That is, it goes to 2 meter. In the second case, again further one more load is added. Totally 2 loads are adding. As a result, the body goes beyond the elastic limit. Even though the loads are removed, the body cannot regain its original shape. That means original length 2 meters. See in the last diagram, once the loads are removed, the length of the string is a little bit greater than the 2 meter. That means the string is loaded beyond the elastic limit. That is why it is not able to come back to the original length 2 meter. Ultimate strength. It is a maximum strength that can be withstood by the given material. Suppose if you add the load or force beyond the limit, necking and rupturing will take place. See, if the stress exceeds the ultimate strength, the strain breaks. This is true in the case of third diagram. The third diagram, 2 loads are added. As a result, the string reaches them crossed the elastic limit. As a result, necking down and rupturing strut. Finally, it break down. ultimate strength is the maximum stress that can be withstood by the given wire or material. Hooke's law. As we saw already, within the elastic limit, stress is directly proportional to strain. This is a Hooke's law. That means within the elastic limit, if we give more stress, means more strain will be developed. That is why the rod stress is directly proportional to strain. It is removed by some constants E and equal sign. The modulus of elasticity E is equal to stress by strain. Poisson ratio. When we apply the load to a wire, not only its length varying, its diameter also varying. So we have to consider both the cases, the length as well as the diameter. When load is applied, the length will be elongated. After removing the load, it will not reach the original length. So change in length is measured divided by original length. That will give the longitudinal strain. Then in the same way, the diameter also varying. If length is increasing and diameter is decreasing. Before that, the diameter is more. After applying the load, the diameter will be reduced because it is elongated. The change in dimension is also noted. The change in dimension to the original dimension, change in diameter to the original diameter will give them lateral strain. The Poisson ratio is the ratio between lateral strain to the longitudinal strain. In this slide, the truss strain diagram clearly explains where the body is in the elastic limit and where the body is in the plastic limit, and the maximum load that can be withstood by the strain also very clearly explained in the truss strain diagrams. Suppose if we add the load beyond the ultimate truss, necking down will start place. Following that, there is a micro crack will be formed. Finally, it will be necked down. Using the truss strain diagram, we can explain the elastic limit region, plastic limit region, ultimate truss region, and necking down process regions. Elastic fatigue, the state of temporary loss of elastic nature due to the continuous strain. Suppose if we operate the rubber band within the elastic limit several times, though we are operating the rubber band within the elastic limit, it loses the elastic property very soon because it is used often or repeatedly. So the state of temporary loss of elastic nature due to the continuous strain is called the elastic fatigue, tiredness. Due to elastic fatigue, the following things are happening. A wire can be broken within the elastic limit. Even within the elastic limit, if the wire is bended to and fro at a fast rate, it will cut itself. A wire can be cut into pieces without using the instrument. Railway tracks and bridges are the declared unsafe after long use. Spring balance showing wrong reading after the long use. These are all due to the elastic fatigue. The elastic fatigue comes due to the repeated usage of the given object. See, elasticity is the property of the material. Using that property, then an object can regain its original shape. The elasticity can be controlled uh, by using impurities. Now we shall see the factors affecting the elasticity. Repeated stress within the elastic limit also reduce the elastic limit of the elastic property of the material. The next one is effective temperature. The increasing in temperatures reduces the